Well, good afternoon, ladies and gentlemen, and extraterrestrial biological entities. Ooh. This is lecture 8.2. We are going to be reviewing the items from lecture 8.1, but in a more formal way. And we are hoping that we will get at least 2 arrays before the end of the class. I will be going ahead and recording the lectures for the parts of the course that we won't get into because of the short length of time in the summer and some issues with Odin and CGI. But we'll talk about those here in the next video, probably. So once again, I'm going to share my screen with you for the majority of the afternoon. And the first thing I want to talk about is let's get back to the ideas of the Hello World program. Again, please remember from the last video that Hello World is generally one of the first programs that we tend to use to experiment a little bit with input-output, to know how we put stuff out to the screen as programmers, to get the basics of variables in, that kind of thing. So what we've got on the PowerPoint right there is one of basically the simplest programs in the world. Now remember, every Perl program starts with the shebang line, pound symbol, exclamation point, /user, /bin, /Perl. But notice also that the shebang line does not have any punctuation at the end of it. It's one of the only times when you won't have a semicolon at the end of a line in the Perl language. Now, let me grab this again. One of the other things that I want you to do is use the modern Perl pragma. So for us, that means the second line that we do would be to use, and we don't want a capital U in use. And our pragma is modern, 2 colons, Perl, and a semicolon. So there we go. That's the majority of things. And I'm going to come down here and make this a little bit bigger. And then the 5th line is actually the line that we utilize to put stuff out on the screen. And again, if you remember last time, we added some \ns, these escaped ends, so that we had a space above it and a space below it, so that our output was floating in the middle of its own cleared space. And that's the way I'd like you to do all your code in Perl. Vertical space is not a bad thing. Also, the last 2 bullet points in here, don't worry about them. Even with Odin, we don't need to use chmod if we're just doing Perl programs. So we're fine with that. Now, you can actually, when it's installed correctly, use command line arguments with Perl. Remember that Perl is an interpreter, so it is not something that is going to compile and then run standalone. It is going to interpret the code through its interpreter and then put this stuff out on the screen. Perl -v, if we do that over here in Perl -v, if we do that over here in our Odin server, you'll see that we're running Perl 5 version 28 subversion 1. We have bumped it up from version 14 to version 28 with the acquisition of the Loki server. Forced acquisition. You can do Perl -e to execute a Perl statement from the command line. If you want to take the time to type all of this in, and I'm not going to do it for us today, but what this will do is it will actually give you basically the same thing that ls does. it gives you a list, vertical along the left side in this case, of every file that is in a specific directory. So if you wanted to go to your assignment 5 directory, for example, or your project directory, that would give you everything that's in those directories. Now, Perl -C basically checks the syntax of your program without running it. We're not going to do anything that's a one-shot program, so to me, this just isn't very important. But if you want to check the syntax of a specific program that you've written in Perl, Perl space -C as a flag, and then whatever your file name is, .pl. I'm not going to waste any more time on it. Again, I think it's more than good enough. We can use the Perl docs, so Perl doc diagnostics, for example. STICS. And what this will do is this will give you just everything that you need to know about a program that basically goes in there and looks at your code and finds out what the errors are and tries to help you. You type in a Q to quit. So just like the Vim tutorial or Vim tutor, Q to quit. Let's see what else we got here. Next one down. There are 3 types of errors in most computer programs. The first is a simple syntax error. It's a spelling error. Something that you didn't put the right punctuation in. Remember that when we print something out to the screen, it's enclosed in single or double quotation marks. So print hello world without putting that double quotation in between the D and the semicolon is a syntax error. It causes the program to crash. Runtime errors are errors that are, a minute, I hate spiders. Runtime error is something like division by 0. If you've got X divided by Y, and at some point Y becomes 0, when the computer goes to calculate the value of X divided by Y, which is 0, will cause it to crash while it's running. It will crash to desktop hard because you can't divide by error. You can't divide by 0, and the computer can't recover from that kind of error either. Finally, there is a semantic error. Semantics, you can kind of think of those as logic. So if we have trying to figure out the area of a circle, and we set up our equation to be my dollar area is assigned the value of integers only, 1 divided by 2 times base times height. Well, there's a couple problems there. First of all, there's just an error in the way you've written the formula, because int says I want to turn the results to an integer. But 1 divided by 2 is 0.5, so 0.5, if we make it to an integer, it acts like a floor function. It goes all the way down to 0. In fact, when you wrap something inside an integer, it throws away all the decimal points and only keeps the integer part of the equation or the result. So this says integer or 0 times base times height, so no matter what your triangle would be, it's a 0. This is also a semantic error. But the real reason it's a semantic error, and the biggest and hardest reason to figure out, is that this is the area of a triangle, not the area of a circle. The area of a circle is pi r squared. This is going to give you a triangle, because circles don't have bases or heights. They have diameters. So remember, syntax error, spelling error, runtime errors like division by 0, something that causes the program to crash while it's executing, and semantics errors are errors that are going to give you the wrong answer because you put in the wrong logic. All right, now we have three basic data types. We talked about scalars the last time. Scalars are just basically variables, just like we use in mathematics. They're a placeholder for a number that we don't know yet, or for, in terms of coding, any type of data that we haven't figured out yet, something that the computer may understand, or by performing a series of calculations, or something that the user may put into our program on his or her own. Arrays of scalars are probably going to be the last thing we touch on this summer. And then we also have associative arrays of scalars, or hashes. And that's probably where your hashtag term comes from. So remember that variables are locations in the memory of your computer that stores data. So we're going to talk about creating a new Perl variable. We're going to call it $greeting. And in order to do that, we have to introduce the keyword my. So to declare a variable, we would say my $greeting, semicolon. That would reserve that little tiny space inside of your memory that we're going to put something into. Now, Perl is not a strongly typed language. In Java, C, C++, most other languages that I use regularly, you have to declare what type of data is going to be inside of this variable. So integer $greeting, or string $greeting, something along those lines. Perl, with the same variable, can hold integers, floats, doubles, characters, strings. Basically, you can put anything you want into a Perl variable. Now, the rules are there are no cases where these vary in Perl. Everything else can do so. Scalar names, variable names in Perl always start with a $sign. They are case sensitive, so you cannot have, well, you can have capital H hello, lowercase h hello, but they're not the same variable. So capital H and lowercase h are different variables in Perl. You can, after the $sign, use an underscore or a letter, but after that first underscore or letter, you can have letters, digits, or underscores as you see fit. So if you go back to the second part of the program that we wrote in 8.1, one of the things we did was, again, use our pragma. We've got my $greeting, so we've declared a variable in line 3. In line 4, $greeting is assigned the value of hello. Remember that a single equal sign in most coding languages represents assignment. What's on the right hand of the equality is being put into the variable, usually on the left. If you see two equal signs, that's saying, is $greeting and hello the same thing? Now, line 5 says print $greeting world. And you remember the fancy word I talked about last time? It's called interpolation. Interpolation says, I am not going to write out $greeting. I'm going to write whatever you've got inside my little memory space in the computer. So in this case, line 4 says, assign the word hello to $greeting. Line 5 says, print hello world. And then we've got our \n there. And you saw in the last video as well that I prefer to have a \n in front and two \n's behind. So we literally have a clear space on the top of our output, hello world, and a clear space on the bottom of our hello world output. Let's see what we got here. Now, what you may have seen or may remember is that in line 4, we use double quotation marks. But in line 3, where we're assigning hello to greeting, we use single quotation marks. We don't have any interpolation to do. There's no special characters in $greeting is assigned the value of hello. So it doesn't matter. But we want to use interpolation in line 4, where we're saying dollar greeting world, and we want hello to come out of that dollar greeting. So single quotes are non-interpolated. Double quotes, on the other hand, give us interpolation. It gives us the inside meaning of the variable rather than having just the variable itself show up on the screen. So if we've got this little code snip, my dollar greeting is assigned the value of hello with single quotes. If we print dollar greeting in single quotes, you see exactly what it prints there on the right-hand side. It prints dollar greeting itself. If you print dollar greeting in double quotes, we use the power of interpolation to actually print what's in the variable, the word hello, out to the screen. Here's our escape characters. You should probably put this into your notebook somewhere where you can come back and look at it again. And what we've got there is the new line character. A horizontal tab /T will give you 8 horizontal spaces. So if you want to print out a few paragraphs of text to the screen, you can start off with /T, and that will give you those 8 spaces in front of each paragraph that you put out to the screen. Now remember, we're not talking about HTML paragraphs here. We're talking about just like a paragraph you might write in an English paper. /A is the system bell. It used to be that every motherboard would have a piezoelectronic speaker on it, and you could utilize the /A to toggle that speaker. If you want to do a backslash, 2 restaurants, La Mesa / McDonald's, you could put 2 backslashes in between them, and that would get one out to the screen. The first one says, I'm escaping a character. The second one is actually what appears to that screen. /double quote allows us to put double quotes on the screen that our users will read. And I think we've got an example of that. No, we don't. I skipped ahead too much. That's okay. Basically, what you'd have is print, double quote, and then if you wanted to quote something, you'd put /double quote, a stitch in time saves 9, /double quote, from Alexander, not Alexander Ham, Benjamin Franklin actually is the one that said that. And then we double quote at the end of that so that we have a print statement. And we'll show an example of that later on, so don't stress over it too much. Just the best way for you to learn it is to sit down in front of the keyboard like I am right now. So now the print statement that we've been throwing around since last week is technically a Perl function. That's why it's got the parentheses at the end of the name. Those are basically those designate that it's a function. I'm not going to get any deeper into that today because it's not going to help us to keep moving forward. The parentheses, basically their task is to hold the arguments that we're going to send to that print function. And an argument is basically, in this case, anything that you want to appear on the screen. So if we come down here to the bottom of the page, print and double quotes hello will give us hello out on the screen. In this case, hello is an argument, 4 is an argument. The value of pi rounded off down there is an argument. If you are printing out a number, generally you don't have to worry about double quotation marks or the single quotation marks, pardon me, unless you want to add some escape characters to it. And we're going to see that, I think, here in the next slide. So this is different ways of utilizing the print statement. Please notice that except for line 7, we've just dropped the parentheses. Perl is one of those languages that says, hey, I already know you know how to do this. So what we're going to do here is we're just going to let the parentheses go. I know they're there. I'll put them in for you. So what we're doing here is we put the shebang line in. We use our pragma, modern Perl. My dollar greeting is assigned the value of hello, just the way we did with the rest of the hello world stuff. Now, what we've got between lines 4 and 5, they look exactly the same almost. But those of you that notice difference, notice patterns, may have seen something that others may not. In line 4, we've got print dollar greeting, a comma, double or single quotes around a literal space in the word world, a comma, and then a \n in double quotes. Well, the \n is to give us a new line character. Line 5, on the other hand, has print dollar greeting, period, the same way we did world before, period, and the \n. What this does is in 4, greeting, world, and \n is called a comma delimited list of arguments. It is a very, very fancy sentence to say, I've got 3 things that I need to send into the print statement. I'm separating them by commas. Line 5 is 1 argument. Anybody ever see one of those old movies where they create a ransom note by clipping letters from magazines and newspapers and gluing them on a piece of paper? That's concatenation. And that's what we're doing here with the periods. So each period says, I'm going to have dollar greeting, I'm going to glue space world to it, and then I'm going to glue a \n at the end of it. So why a comma delimited list sends 3 arguments, or whatever the number of arguments are. A concatenated list turns all 3 of those into 1. Now, line 6 is everything involved is in double quotation marks. That means we have 1 sentence that we're pushing through. But that sentence, because of the double quotation mark, happens to be interpolated, so we'll get hello world out to the screen. But it's still only 1 argument that we're sending into the print function. Finally, line 7, if we look at it, it's got commas in there. So hello, the value of pi is, comma, that's the first argument. 3.14159, that's the second argument. And then a \n for our word return, our carriage return, is 3 arguments. Let's do this real quick. I'm not going to print all of these because they're pretty self-explanatory. But let's vim test1.p here. And of course, we always start with the shebang line. We always start with the insert key. And then we do the shebang line. And user/bin/Perl. And we're going to use modern. Oh, doggone it. How did I get that? Oh, I know. Never mind. It's an error in my vimrc. So we're going to use, that's the way it should look, and modern, 2 colons, capital Perl, and a semicolon. And then we want to, is that going to do it? No, it's not. So let's print this out instead. Come on. I always forget the insert key. So we're going to print. The parentheses are there. It's okay. Again, they don't have to be. Hello, the value of pi, is, double quote, comma, 3.14159, comma, and then we want our \n. We want to do our parentheses, and we want to do our semicolon. Now, one of the things I am going to do up here is I'm going to use a different function called say. And all that's going to do is add a new line character up there. And I'm going to do the same thing down here. I'm going to include a \n in there. The reason I'm using say is like a print statement, but it adds a carriage return at the end of it automatically. So I'll have one \n at top. At bottom, I'll have the \n from say plus an extra one that I'm telling it to put onto the screen. Let's escape, write and quit, and let's Perl test1.pl. Below the value of pi is 3.14159. We got a couple problems there, though. If you were raised with strict English teachers the way I was, you'll notice that is and 3.14159 run together, and there's no period at the end of the sentence. So let's real quick go back up here and fix that. Well, what do you see between the 3.14159 and the word is? Hopefully, you see that there is no space in between the double quotes. So let's hit the insert and space there. Now, always remember that you will get out to the screen exactly what you type in between your single or double quotation marks. So if we do not have a space in front of 3.14159, and we won't since we're just printing a number, then we have to make sure that we add a literal space, and that's what it's called, a literal space where we need it to make our output look good. And I'm going to go back up to this sentence, and right in front of the \n, I want to do a period. Again, my great aunts were English teachers, and if they saw me outputting this and teaching people incorrect grammar in English, grammar, thank you, they'd roll over in their graves at best. So there we go. Notice the difference. We put a literal space in after the word is. So now we have a literal space after the word is, but before the approximation of pi. And before we did the carriage return, we did a period behind the value of pi. Now it's a complete sentence, and it's that little tiny stuff that can make the difference between a great looking program output and something that you're not going to get full points for. Okay, so let's go back here and let's take a look at our next one. Now, we already talked about this. This is called the diamond operator. And this is our way to capture what is coming in on what's called STDIN, or the standard input. So print, enter a greeting. My $greeting is assigned the value of the diamond operator, takes whatever the user types plus the return key, which gives us a \n, and stores it in a variable, a scalar called $greeting. Now, if we print $greeting, we'll get whatever their message is. Then we print 6. This follows the greeting. Notice we don't use the $sign there, so that's just a standalone sentence. We're not worried about the $sign. We don't want to see Rumpelstiltskin or whatever our user typed in line 4. But there's something peculiar that happens when you're doing that, and I want you to see that too. So let's vim test2.pl, and we're going to hit our insert key. There we go. Oh, for crying out loud. Well, oh, for crying out loud. I don't want to send it to there. I want to do Perl. And we're going to use modern 2 colons, Perl semicolon. And what we're going to do again is we're going to ask for a greeting to be entered. Now watch with just the print statement here where our user types. I'll give you a clue. It's going to be immediately after the space behind the colon. So let's watch that. So printer or print enter a greeting. Now, the thing with the print statement is it does not give any carriage return at the end of it. You remember I used the say function in the last one? So I said say, we'll put a \n up there. Well, print doesn't. That allows this my dollar greetings assigned the value of the diamond operator to be printed on the real screen right after that space behind the colon. I think I said that before. Now I'm going to do this. This follows greeting. And I'm going to add a couple of \n's just because I hate so much for everything to smush together like it does. So we're going to save this, write and quit. Now it's Perl test 2. Enter a greeting. Salutations. Let's try that again. Oh, I know what I did, didn't I? Yeah. So let me go back and I'm going to use single quotes. Let's see if that does anything for us. I usually do this by default. Oh, there's another. There we go. See the comment? That shouldn't be at the end either. So let's try this again. There we go. So enter a greeting, howdy, and then this follows the greeting. Now let's take a look at the chomp function. The chomp function removes a \n from the end of a scalar if it's present. Usually that \n only comes from hitting the enter key at the end of a line of text. The chop function, on the other hand, takes any character off the end of a specific sentence and makes that happen. So here's what I'm going to do. I want to do some of this stuff a little bit differently here. So bear with me. There we go. All I'm doing is bringing in Linskip so I can do things a little bit quicker here. I am running so out of time. We're in summer 20, and there we go. So this is kind of fun. What we've got here, I don't know if you guys used to ever, when you were little, have the books called Mad Libs. It was a way of faking kids into learning English. At the same time, they were having, you know, kind of subversive fun, actually. And what would happen is they'd put out a book of, you know, just little tiny stories. And then they would ask, give me any noun in the book, give me any adjective in the book, give me any verb in the book, and you'd string them together. Now, we're going to do that next. I want to get to this first, And this will help explain a little bit what goes on in the Mad Libs, all right? So what we've got here is my dollar string says this has a new line and it's got a \n on it. We say dollar string and we'll have 2 \n's at the end of this. So we're going to have this has a new line and 2 vertical spaces underneath it. We're going to chomp dollar string once. That should cut us down to just, just the phrase, this has a new line, and right up underneath it, we'll see this now there's no new line. We're going to chomp it, and we're going to say, again, string. So remember, that's going to have an automatic new line with it. But it's not going to be the 2 sentences butted up together like it would be with a print. We're going to chop dollar string. Remember, the difference between chomp and chop is what they do. Chomp takes off any new line characters like this one. Chop takes any characters off. So now there's no new line, period. After it's chopped here, we'll say, now there's no new line. We're going to create a scalar saying that says, my dollar save me holds on to whatever we chop up of dollar string. Now, since dollar string now says there is no new line without a period, what's going to happen is we're going to save the E and we're going to print it as now there's no new lin, L-I-N, and then save me is going to print out an E. Okay, so let's save this here real quick. Oh, and I saved this as Mad Libs even, didn't I? All right, so let's vim madlibs.pl. You'll see all we're doing here is the string, the chomp, and the chop. So let's Perl that. The first one has an extra \n in it, so we get rid of one of those. Well, one of those turns it down into the next line, and then we have the extra space. The second line, we get rid of one of those, and now there's no new line, or this has a new line. But we chomp it now. There is no new line, but we're getting one there with our save function. We go ahead and chop it again. The period disappears and we get now there's no new line. We're going to save in save me whatever we chop from the back end of the now there's no new line, and you see it becomes now there's no new line, and then we print save me and it's an E. So it's really kind of cool. You could actually pick apart a regular string of letters, a sentence, and then using the idea that you're saving each individual letter in a variable, you can play around a lot with that. Now, let's go back and do the Mad Libs thing now. And we're going to get rid of that one, and we're going to come back and do, we're just going to call it mad.pl. Now, I want to grab a hold of all of this. Now, one thing you can do is you can just highlight everything with the mouse as I'm doing here, and then copy it, or you can hit Control A and then Control C, which highlights all and then copies it. And we're going to paste that right there, and then Control V, by the way, is a keyboard shortcut to paste for Windows products. So we're going to ask our user to pick a number between 1 and 10. My $num declares the variable. $num equals a diamond operator. Diamond operator initializes it with a value that our user types in, and then we're going to chomp $chomp $num, and that is going to take the invisible \n of the hitting the keyboard with enter. Then we're going to ask for a noun. We'll do the same thing, and then we're going to ask for a verb. Now, notice in the noun we combine 2 steps. We combine the declaration, the initialization of noun. My $noun is assigned the value of the diamond operator. So we declare noun and we initialize, we fill it up with the noun that our user puts in. Finally, the verb, if you look at the chomp line, we are doing exactly what we did in 3 lines for my $num in 1. So we're going to chomp inside of the chomp's parentheses. My $verb initializes it, and the input of our user, my $chomp declares it, and then we initialize it with my $user's input. This is the wrong day to be recording videos, I think. So chomp, my $verb is declaring the variable. The diamond operator from the user initializes it. That's what I was trying to say. Now, if you look down below, $verb is assigned the value of a minus .verb.ing. So remember what I said about concatenation a minute ago? So if my .verb was run, it would be a running once we stuck it back into $verb. So literally what this says is $verb is assigned the value of prepend a minus, add the verb to it, and then append ing on the end. So if the verb is run, it's a running. Some of you may already recognize the song that we're going to kind of play around with. And then notice at the end, our output is so difficult. Print \n, and we want $num. Whoops. I still haven't got that spider from about a half an hour ago, if you might have noticed there. So we're printing a \n on both ends, so we get some separation, and then $num, $noun, $verb. It sounds a lot more complicated than it is, but we're going to go ahead and close this out and minimize this. And we're going to come over here and we're going to Perl, mad.perl. Pick a number between 1 and 10. Let's have 9. Give me a noun. How about lords? Give me a verb. How about leap? 9 lords a leaping. Not bad. Now you know how to build that entire Christmas carol if you're of the persuasion of caroling. If not, there's other songs out there that you can turn into little silly Mad Libs too. So basically what we need to do there is we need to remember that if we're accepting input from our user, we should always chomp that \n off the end. I'm not going to go through this because the IMDb film CPAN module has not been updated. I need to put something else in there, but we'll take a look at, or you can take a look at something else as you move along through your career. We're going to get rid of 18 and go right into 19. And 19 follows on with some of the things we did in our 8.1 video, which is math. Everybody loves math, right? Well, Perl has got 5 basic types of arithmetic: addition, subtraction, division, and modulus or modulo. Now, what we're going to do is I'm not really going to lead you into all the heavy duty, brainiac discussion of modulo. For us, let's just think of it as the remainder left over after the step of long division. So 4 goes into 6 once. 1 times 4 is 4. 6 minus 4 is 2. 2 is the answer to 6 divided by 4. At least if you're doing it with modulus division. So let's take a look at some more examples here. And I'm not going to do these because you can sit down with a pencil and paper and do them. Or I would strongly suggest you type some similar things into your Perl compiler, or Perl interpreter rather, and see if you can do them both on paper and in the computer and get the answers to match. That's the best way to learn this stuff. We're going to talk about order of precedence here in a bit. Now, if we want integer division, and you remember we saw that on that semantic error page, we want to have basically with the int function, we're casting it to an integer, which means we're throwing away any decimal points. So again, you know, 1 divided by 2 gives us 0.5, but wrapping it in an integer gives us 0. Okay? So, the integer in parentheses, numerator divided by denominator is regular division, but it's regular division with whole numbers only. If you know what a floor function is, it functions a lot like a floor function, which just says always round down no matter how big the decimal point is. Numerator mod denominator will tell you what's left over. And that's exactly where we need to be. So here's a little program that shows you what happens with regular division and with integer division. So 10 divided by 2 is 5, 10 divided by 3 is 3.33. If we were putting an integer around it, as you see in line 11, that would be just the 3. 10 divided by 4. 4 goes into 10 2 times, and there's 2 left over. That would be 2.5 if we did regular division. But all we're going to have with integer division is a 2. If we divide 11 into 10, we get a 0 when we do the integer. Because it doesn't, 11 doesn't go into 10 at all evenly, but it will go into 10 when you add a decimal point and make it 100. So we wind up with 0.9090, etc., repeating, but when we apply the integer cast around it, it becomes 0 because we take the decimal points off. What would 10 divided by 6 output in terms of integer division? If you said 1, you're absolutely right. Now let's take a look at modulo. X modulo 2 has no remainder. 2 goes into 10 5 times. There's no decimal point. There's nothing left over. So that becomes a 0. 3 goes into 10 3 times with 1 left over. Hence the modulus is 1. 4 goes into 10 twice with 2 left over. 5 is a perfect division, so we have nothing left over. 6 goes into 10 once with 4 left over. 11 goes into 10 0 times with 10 left over. So that's how we get those. So we don't, you remember PEMDAS from high school? Parentheses, exponents, multiplication, division, etc., etc. Addition, subtraction is etc., etc. It didn't make sense to stop it there. But we have an expression called the rules of precedence, or we have a rule of precedence for the expression, is the way I should have said it. Operators within parentheses are evaluated first, from left to right. Then we evaluate multiplication, division, and modulus, again, from left to right. After all of those are done, then addition and subtraction are evaluated last, and once again, we go from left to right. So here's a few examples. I don't want to put these on the computer, not because I don't think they're easier to solve that way, but because I think what you need to do is you need to figure out how to make an equation on paper that matches what you put into the computer. So notice the stars. In the first one, my $x, the very first thing we do in our rules of precedence is 7 times 8 is Well, the easy way to do it is 8 times 8 is 64 minus 8 is 56. Or you could have sat down throughout like the first 3 grades of your life chanting multiplication tables till they were in your head. So that's the first thing we do because it's a higher precedence than addition and subtraction. Then we do the 5 plus 6 for 11. That's number 2 because we do addition and subtraction from left to right, same level of precedence. So we've got an 11 minus 56, which is 45. And if you look down below, that last line in the bullet point says minus 45. My dollar average, because of the parentheses, we add the first 4 addition problems, and then we divide the whole thing by 5. And I'm not going to walk through the other 2. What I'd like you guys to do, though, is sit there with a piece of paper and a pencil and try and figure out how the computer makes it happen. You'll be amazed at first how many times you make simple errors, but the more you practice these, the better off you're going to be at making sure by hand that the math you put in the machine is correct, or vice versa. Now, remember we talked about concatenation, using the period to kind of string multiple words into a single word. And if you had looked at closely at the Mad Libs, that's exactly what we were doing there. Remember a running or a leaping? So my dollar noun is declared and initialized as holding KID, kid. Dollar noun is assigned the value of $9 concatenate S. So what we're doing is we're taking dollar noun, we're adding an S to the value inside of it to make it kids, and then we're putting it back into dollar noun. The third statement says, okay, that's cool. Print it out to the screen. And with the appending of S to noun, we get kids, and that's what prints out to the screen. My dollar word equals BA X4. This is not a multiplication. Remember, multiplication in computer terms is generally the asterisk, right? That's the star over the number 8 on your QWERTY keyboard. But what we get there is we say, I want you to print the word BA, or I want the word BA to be put into dollar word 4 times. So ba, 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 ba. And then we print ba, 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 ba. My double Z equals 8x8. That is not 8 times 8. That is the number 8 times. Third one there is really kind of cool. Dollar A is assigned the value of XY, X2. So we get XY, XY. Concatenate a Z to it. So we get XY, XYZ. We do that twice, XY, XYZ, XY, XYZ. In the old days when we were using basically output to the DOS screen as a default, we'd like to put the equivalent of horizontal rules in a web page in our output. So we could do something like print the equal sign 78 times, and on an 80 column monitor, of course, that gives us 2 columns on the right hand side left over, which is just good enough for us to look at it as a full screen width delimiter. Just like I said, a horizontal rule. Let's take a look at the last of these. Now, noun is assigned the value of noun concatenate S, right? It's a pretty simple idea. You take whatever's on the right and put it back into the variable on the left. So even though kid was originally dollar noun, when we added the S to it, we put it back into dollar noun, and dollar noun had kids. That sounded weird, but that's basically what happens. Now, if you look at this, this really isn't any more scary than what we were doing just a moment ago. So you see my $KF is assigned the value of 3. Then we have something we haven't seen before. We have a plus equals. This is the first step in making it really easy and saving us some steps to put a new value into $KF. So if KF originally enters equals 3, or is assigned the value of 3, then we have 3 plus 4 equals 7, and we put it back into $KF. And we can do that with all of our operators like that. So plus equals, minus equals, star equals is multiplication. So if KR is 5, we star equal 3, we get 15, and 15 goes back into KR. Division assignment. Divide equals 5. What do we got on the next one here? There we go. Modulus assignment, concatenation assignment. We're even using the same example that I used back when we were doing the Mad Libs thing. And then we can also do repetition assignment. So word x equals 3 gives us blah, blah, blah for our word. What else do we have here? Perl does have an exponentiation operator built into the language. If you don't know what exponentiation is, go back and review your algebra. Exponentiation is 2 times 2 is 4. Remember, 4 times 2 is, or 4x2, 4 to the second power is, 4 times 4 is 16. 3 times 3 is 9. 5 times 5 is 25. But it's 5 squared is 25. Right? 5 cubed is what? 5 times 5 is 25 times 5 is 125. So that's the way we do it. In terms of Perl, though, you would say my $num is assigned the value of 2. Num star star equals 4. So that's going to give us 2 times 2 is 4 times 2 is 8 times 2 is 16. In other words, 4 to the or 2 to the 4th power. Now take a look down here. In this very, very last one, notice we have minus 7 star star 2. Well, that's 7 squared, right? Yeah, except not. Here's the reason why. When we're talking about doing something like that, the minus 7 has, or the minus, the unary minus sign has a lower precedence than exponentiation. So what we actually have to kind of treat this as is, you know, the minus 7 just sits out there like a minus 1. So what we're doing is, imagine there's the minus 1 out here times in the parens, 7 squared, which is 49. Then you multiply that by the negative 1 and it becomes minus 49. This whole long drawn out windowed explanation is simply to point out that if you want to exponentiate a negative sign with an even exponent, you need to put parentheses around the negative 7. Okay? Now, there are basically 3 ways to increment values to a variable, a scalar. The long, clear way, $x is assigned the value of $x plus 1. And if we're just looking at plus 1, this works very well. At least the last one does, and I'll show you that here in a minute. X plus equals 1 is the one we were talking about just about 4 minutes ago. But there's also a super, super short way to increment a variable by 1. And that is the variable name plus plus. C++, that was one of the bits of its language that caused it to get its name. So X++ is called an auto increment. X minus minus is called an auto decrement. And there's 2 other things we have to remember here. We have to remember whether it's in front of the $x or behind the $x. So X++ is post increment. It says, do whatever you're supposed to do and then add 1 to me. Plus $x is pre-increment. It says, add 1 to me and then do what you need to do. Sounds kind of funky, but it is important in some cases where you are going to be working with other values, especially when you're doing stuff inside of your code. So here's what I'm going to do. We're going to do a quickie example with this. And we're going to vim text test3.pl. And again, remember, we always start with the shebang line. Oh, and guess what I forgot? And then I'm going to have my pragma. And you know what? We're going to save this. I'm going to go back over. I had forgotten actually that I had WinSkip open. So let's do that here. Whoops. So we want to open test 3. You need to refresh it. So just right click and refresh. Now, I'm adding a my there so I don't run into any errors. My $x equals 6. Print $x plus plus. So that says do what you need to do first and then add to it. So it's going to print 6. We'll add to it, or we'll print it first and then add to it. It's going to be 6, 6. Plus x says add to this first and then print it out. Well, let's just see what it does. You guys are going to get lost in my explaining it in English, so let's take a look at it first, and then we can take a look at how to make everything else run. Come on, you bloody thing. There we go. No more spiders. Unless you brought a friend. Or she brought a friend, as the case may be. All right, so let's save that. Let's come back over into, oh, bloody hell. There we are. So let's just go ahead and vim test. And you see everything is there. Print x plus plus, print x plus x, print x. Okay. And let's Perl test3.pl. Oh, and you know what I forgot to do? I forgot to add my \n, but you can see right over here, 6, 7, 8, 8. So we start out with 6. We print sorry, I keep adding 1 into it. So we start out with 6. We say print the number 6, then add 1 to it. We print $x again. We get 7. We get pre-increment, which says add 1 to it and then do your job. That's why we get the second 8. And then print $x just gives us the 8. So here's what I'd like you guys to do is let's get you to make a prediction. Make a prediction about what's going to happen when you change the x plus plus and the plus plus x. Put them into different, or flip them around. Leave the rest of the program the way it is and flip the pre-increment and post-increment and see what you get. So I'm going to do this. You can shut the video off or pause it for a couple minutes and see what you get. There we go. So again, all I'm going to do is that. I'm going to change the pre-increment and the post-increment around. Okay. Got it saved. And whoops. So you can see them right here. Doggone it. The first run through was 6, 7, 8, 8. The second run through, though, with them changing where they are, becomes 3 7s and an 8. Now, you should be able, by just this slide and this explanation, be able to grab a hold of it on your own and walk through it and tell yourself why. If you don't get it, you can always come back or send me an email and I can explain it to you. But this is a good self-exam kind of test that will allow you to know that you're thinking in the right space. So the last slide here is another one of those that you'll probably want to keep a hold of, especially if you go on into doing more programming after this. Parentheses comes first in order of presentation, then our increment or decrement operators, and our exponentiation operators. Our signs, positive and negative numbers, are after exponentiation, which is why that minus 7x or star star 2 worked the way it did in the slides. Then we have multiplicative, and remember it is associated from left to right. So it doesn't matter whether it's addition, subtraction, multiplication, division, modulus, or repetition. Those all come first. And again, they go from left to right with the multiplication and the division and everything on there having the very same level of precedence, so just left to right. Addition, subtraction, and concatenation, though, are done last. And again, they go from left to right to complete the problems. And it should be relatively easy that way. Pardon me. And then our compound assignment operators, the ones we went through most of the slide set with, are basically there at the last level of precedence. Okay? Enough said there. We're going on to set 20 quick. And then after we have our Q&A tonight, we will go back and take a look at a couple other things, including arrays. So this, we're talking about logical operators. We're not talking about anything fancy. We're just talking about and, but, and not. Well, not even but. And, or, and not. Whenever I see these, whenever I talk about these, I flash back to the old Scholastic Schoolhouse Rock things. There used to be a railroad-related cartoon that said, you know, conjunction, junction, what's your function kind of thing. And there's a lot of similarity there, except they're talking about and, but, and or will get you pretty far, but we're talking about and, or, and not. 2 ampersands is a logical and. 2 pipe characters, and the straight up pipe character is the shift backslash above the enter key on your QWERTY keyboard. And then the exclamation point, bang, stands for not. So let's see where we're going here. So what we're doing is we're trying to make decisions like an if else. Did we get these out of order? We did get those out of order, didn't I? Yep, let's get the if statements first. Hang on just a second. You know what? Let's go ahead and close this off here, and I'll bring up a new one, and we'll talk about if statements, and then the and, the or, and the not.